Okay, so this is for patterns and sequences practice. Oh, I want to. Okay, so 1A says, for the arithmetic sequence below, find the common difference in the next three terms. So remember, our common difference is the number in which each of my terms are changing by. So when I go from 12 to 16, I know I'm increasing by 4. And from 16 to 20 is increasing by 4, 20 to 24 is increasing by 4, and 24 to 28 is increasing by 4. So that means my common difference is 4. Okay, so now for my next three terms, starting from 28, all I need to do is add 4. So that would give me 32, and then I'll add 4 again. You're going to McCoy's? Okay. 32 plus 4 gives me 36, and 36 plus 4 gives me 40. Okay, so now for 1B, I want to identify the rate of change and my function rule. My function rule is going to be in the form of y equals mx plus b. Okay, so for my rate of change, I'm just going to do delta y over delta x, or you can easily do your stat edit here. So I see from 12 to 16, I'm increasing by 4, and from 1 to 2, I'm increasing by 1. So then that means my rate of change would be 4 over 1, which is just going to be 4. Okay, so now for my function rule, I just need to find what my 0 term number, or the term value would be for my 0 term number. So, and I know this one's going to be 0 because this one's adding 1, so to go backwards, I subtract 1. And the same thing I'm going to do over here. If I'm increasing going this way, then backwards I'm going to decrease. So I'm going to say 12 minus 4, which is going to give me 8. I could also just punch these values into that stat edit and get the equation that way. So that means my function rule is y equals 4x plus 8. Okay, and then my next three terms, so 6, 7, 8, I know that they're increasing by 4 each time. So then this one is going to be, yeah, right here. No, you're fine. So this one will be 32, 36, and 40. 36 and 40. Okay. All right, so what do you notice about the sequence in 1A and the term values in 1B? Well, they're exactly the same. So again, I'm looking at the sequence in 1A and then my term values in 1B. So what do you notice about the common difference in 1A and the rate of change in 1B? So we can see that they are exactly the same as well. I totally misspelled that. This is supposed to be they are. So they're exactly the same. Okay, so how did you determine the next three terms in 1A and in 1B? We added 4 to the previous term. Or I'm going to say added 4 to previous term. Okay, so we can use a linear function rule to represent an arithmetic sequence. We do that by just recall whenever we put this, our first 2 points in stat edit to find out what our function rule is, then we can find out what any term value is from the term number that we're looking for. Okay, for 2A, for the arithmetic sequence below, find the common difference in the next three terms. So again, to find the common difference, I'm going to see how it's changing. So I see that it's decreasing. So I know this one's minus 5, minus 5, minus 5, minus 5. So that means my common difference is minus 5. So therefore my next three terms would be 5, 0, and negative 5. Okay, so for the sequence in 2A, create a table of values. So my rate of change is going to be, negative 5. So that means my function rule, well, what I'm going to do is plug in my values from over here, and then I'll find my 0. So 30, 25, 20, 15, 10. So I'm going to go backwards. So that means when I go backwards, I have to add 5. So this would be 35, and then I would just be subtracting 1 here would be 0. So this is going to be y equals negative 5x plus 35. And then my next 3 terms are going to be just like this over here. So 5, 0, negative 5. Okay, so circle the sequence below that are arithmetic sequences. Hey, did you include this in here? Because technically it is, right? It's not.
I thought it was a part of it.
Maybe it is. That's hilarious.
Yeah.
Okay, so when I look at this one, I see that it's increasing plus 8. This one's plus 8, plus 8, plus 8. Since they all share the same common difference, then that means it's arithmetic sequence. For this one, it's plus 3, and then it goes plus 6, so that means this one is not. And this one goes minus 6, minus 6, minus 6. So then this one would be, this is all together. Okay. So how do you determine whether the sequence was arithmetic or not? It would be if the sequence has a common difference. All right. So for each arithmetic sequence, find the requested information. So we have 3, 9, 15, 21. So it wants to know what our D value is. So I know I go from 3 to 9, adding 6. So that means my common difference is 6. My next 3 terms are going to be 27, 33, and 39. Okay. I'm going to fill out my table over here. So term number 1 would be 3, and then 9, 15, 21. Okay, so I'm going to make my function rule. So it's going to be y equals 6. Y equals 6x. So let's see. I know that I'm increasing by 6 each time, so to go backwards, I'd have to subtract 6, so that would give me negative 3, and this would be 0, so therefore it's going to be 6x minus 3. So now I'm going to go to y equals with that equation, and then the table, and then I can see for A1, we have 3, which we already knew. Our first term was 3, just based off this. And then my 6th term is 33. Okay. Number 5. I didn't even need that table for that one. But I will on this next one. Okay. So here, my common difference is going to be minus 6. So then my next 3 terms are going to be 81, 75, and it would be 69, right? Yeah. Okay. So my first term is going to be 105. And then my 8th term, well, I have 4 here, 5, 6, 7. So again, I would just subtract 6. So it would have to be 63. And then for my function rule, let me fill this out. So 1, 2, actually, what I'm going to do is 1 here, 2, 3. I'm going to make this one 0. So I know 1 is 105, 2 is 99, 3 is 93. And then I know to go backwards, I'm going to add 6, so it's going to be 111. So this is going to be y equals negative 6x plus 111. Okay, so now on the back side. So finding terms of an arithmetic sequence with the common difference. So we have 3, 7, 11, 15. It wants to know what is the common difference. So I just look to see what number it's changing by each time. So it's by 4, so that means my common difference is 4. And they've already given me the first 4 terms, like this is my 4th term right here, 15. So that means my a sub 5 would have to be my 5th term, which is going to be 19. Okay, on the next one, I see that they have a common difference of negative 3. And so my 6th term, well, my 5th one is going to be negative 12. So that means my 6th one's going to be negative 15. All right, so write the first 4 terms of the sequence described by the given formula. So I know my first term is this one, 12. And then this right here is just like my recursive formula. So this one is my D value. So I know I'm adding 7 each time. So my next one's going to be 19, and then 26, and then 33. Okay, so now write the first 4 terms of the sequence described by the given formula. So again, my first term is going to be 10.5, because it tells me a sub 1 is 10.5. Again, this is my D value for my recursive formula. So I know I'm going down by 4 each time. This is supposed to be a point here. So I'm going to take, let me put here. So I'm going to take 10.5 and subtract 4 from it. That gives me 6.5. Then I subtract 4 again, I get 2.5. And then I'm going to subtract 4 again, and I'm going to get negative 1.5. Okay. So it says, suppose an arithmetic sequence has a common difference of negative 2. What is the next term after 45? Well, we're just going to take, or subtract 2 from it, so it's just going to be 43. Okay, suppose an arithmetic sequence has a common difference of 10, so D equals 10, and it's telling me that a sub n equals 68. So what is the value of a sub n minus 1? This a sub n minus 1, this is my previous term. So what I need to do is take this 68 and subtract 10 from it, since I'm going to go backwards, and that means my a sub n minus 1 equals 58. Okay, the next one says, for the following sequence, determine ace of 22. So what I'm going to do is set up a table so I can find what my function rule is. So I know 1, 2, and then 40.5 and 41. So I'm going to stat, edit, 1, 2, and then L2 is going to be 40.5 and 41. Let's get our equation. So it is y equals 0.5x plus 40. We get that from our calculator, and then we're going to go to y equals and put in 0.5x plus 40, and then go to the table. And we're going to look whenever x is 22 what our y value is. That's going to be our term value. So it's going to be 51, so equals 51. Okay. So number 13 says, in a certain arithmetic sequence, a sub 6 equals 15 and d equals negative 2. And it wants us to find ace of 10. Okay, so if I have that ace of 6 is 15, then I have 7, 8, 9, and 10. That's what I'm trying to get to, right? Yeah. So I'm going to just subtract 2. So this would be 13, 11, 9, and 7. That's my answer. Okay. Determine ace of 25 for the arithmetic sequence with ace of 1 equals 80 and ace of 2 equals 76. So I am going to find my function rule first. So 1, 2, and then I have 80 and 76. So going to stat edit. So I don't need to change this side because I already have those values in. So I just need to change L2, which is going to be 80 and 76. So I'm going to go back to stat and then calc. So I have that it is y equals negative 4x plus 84. So now I'm going to go to y equals and input my equation and look at the table, and I'm going to whenever x is 25, I want to see what that term value is, and it's negative 16. So that means ace of 25 equals negative 16. All right, and the challenge. So we have to fill in the missing terms of the arithmetic sequence. So all I'm going to do is first find out what my difference is between 44 and 76. So I see that they have a difference of 32. And then I'm going to see how many spaces they have between them. So 1, 2, 3, 4. So I'm going to take this and divide it by 4, and that means I have a common difference of 8. So therefore, I'm going to say 44 plus 8, and I'm going to get 52 plus 8, which is going to be 60, plus 2 is going to be 68, and then plus 8 would be 76. Okay, so that is all for the worksheet.
Is this how it's supposed to look, or is it like a